Lesson two, or I'm sorry, not lesson two, lesson one still, module two, if you will. I promise to make this one a lot shorter. What we want to talk about right now is just variables and how you assign or bind these names to different numbers. So I'm not going to repeat anything that Dr. Bell did in her lecture. But I will sort of maybe add on to some of the stuff that she talked about. But make sure that you go back and you watch that video. So, and she talked a lot about syntax and semantics, and it sort of made a lot more sense to you. I will hit on a couple items though, so just the ones that I feel they're most important to us. And oh, by the way, we are coming across our first operator in the Python language, and it's the equal sign. So you'll see the equal sign, a equals 3, b equals the string 4, c equals 5.0. That equal sign is an assignment. It's not the same thing as an equal sign in mathematics. So make sure you go back and you check out that video because she talks about that a little bit more. Okay, so let's talk about what happens in the computer. And again, I'm not going to go through all of the. So we're going to call this memory. I'm not going to go through all the particulars inside the memory when it starts allocating memory and all this other business. But I'm just going to say I'm going to let this little cloud symbol here represent our memory, and we'll say this binding here, this box represents the letter A or the symbol A, and then in memory there's a location for the number 3. And so what happens when you set this A equal 3, you're binding that A to the memory. There's a memory location, and we'll see that here in a second what that memory location is. It really doesn't mean anything to us, so in general we don't use that a whole lot, but it binds that letter A to that memory location, that when we say print or we do something with it, the number 3 comes out of it. And you might see also, so we're gonna do this here in a second. We're gonna bind B to the string 4. And then we'll bind C to 5.0. So that's what we're going to do. And then we're going to see sort of what happens with some of these other things, right? Because we think that A plus C should give us something, because this is the second operator, this plus sign. This plus means something, and what it means is to do something based on what this type is and what this type is. And because A and C, so A is type int plus type float, then what it does, because this is a float and the 3 is an int, and so what it does is it does addition slash mathematics, so math. And then A plus A, obviously 3 plus 3. Oh, and the other thing is what comes out of it, right? So it's going to do addition and math, but what comes out of on the other side is a type of a float. When you add an integer and a float together, that tells you that a float comes out. If I add two integers together, 3 plus 3, then I expect 6, which is a type integer. A plus B, what does it mean to take a number 3 and add 4 to it? Probably an error, right? So we'll see that here in a second. So it doesn't really mean anything. What does it mean to take an integer and multiply it by an integer, right? So in this particular case, A times some scalar 3, so 3 times 3. So start thinking of these things as, okay, this is an integer, and I'm doing the operator, this multiplication operator to it, and then another integer is on the other side, so this is going to give us an integer as well. All of this business is how much memory how much memory that we're going to need over here in this place, right? The integer needs less memory than a float. A string, it just sort of depends on the number of string characters that you have. But just understand the computer does all of that for us, and that's a topic for another class on how to allocate memory and all that stuff. So B times 3. You might think that, okay, I'm going to take the string 4 and I'm going to multiply that by an integer 3. What does that mean? Well, it just so happens that strings do have or know what to do with an operator of a multiply sign, right? So what does it do then? It just takes a b and it adds a b and it adds a b. Well, what is that operator? So that operator means take the 4 and put it right next to 4 and put it right next to another 4. So that's what it does. So it returns a string with those 4 characters repeated 3 times. So that's the idea behind that, right? So it's going to do something, and the reason why it knows to do that, and it doesn't do that for an integer or a float, is the fact that it is in fact a string. And so knowing that it's a string, we'll know what sort of things that a multiply operator does to it. And obviously this will be 15.0 or a float, and it's going to do math. So it knows what to do. And then this b plus b plus b is the same thing as happens there. So the plus operator, when you put 2 strings, so string 1 plus string 2, all that does is concatenate. So if you've ever heard of the word concatenate, it puts the string 1 and the string 2 right next to each other. So there's no space in between. If you put a comma here, then it would put a space in between. But again, Dr. Bell is going to talk about all of that stuff as well. And it, of course, this is math. And because it's 3 integers, it's going to be an integer. And this is also, I think we've already even done this one, so I don't even need it. Okay, so let's go to Python and see what happens. So a couple of things that I want to introduce here is maybe some things that allow us to have shortcuts. Maybe some things, if you run stuff in here, it's going to help you exit. So if you get caught in sort of an infinite loop, you go to consoles, or if you're in a position where I just want to restart the console. If you restart the kernel and it says, "Are you sure?" Because you're going to lose everything. Then you say yes, and then what happens is you'll see restarting kernel, and then it comes up with the number 1 here, because that's the first thing that you're entering, and there's nothing up here in your variables that's been defined. So we've restarted the kernel. We're at a spot where we're kind of new, and everything we put in here is new. And I'm going to put F9, and so what happens when I hit F3 here, you get the letter A is now binded to some memory location that contains the number 3. So that's what that sucker's doing. And then just for purposes that we will sort of identify here in a second. So I'm gonna identify 2 more 3s. I'm gonna say A1 is also equal to 3 and A2 is also equal to 3. And we'll see hopefully in a second why we're doing that. And then we'll say B is equal to the character 4, or the string 4. I guess there's 4 characters in the letter or the word 4. And then C is equal to 5.0. That's a float. And then let's find out what happens. Let's look at, see how Python vision or sees what these letters are, right? So type will tell you what type it is, right? So sort of hopefully that makes sense. And in this case, if you look down, type of A is an integer because you binded the letter A to a memory location that contained an integer. So that's where you get that from. And then type of B, oops, I didn't do that. All right, so let's try again. F9, maybe I didn't hit F9. So F9. It looks like we got them all now. And B is of type str. So str represents string in Python. And then type C is a float. So these are all objects, and they all of our objects have types, and our types are now binded to some place in memory that contains these type of numbers. Okay, so let's see how can I find out print. Let's print hex ID A. So what this is going to do, so the IDA will give me the number, the number base 10 of the memory location where A is pointing to. and then I'm just converting it to hex because that's what you should be used to seeing a memory location in hexadecimal form. It's just a different base, and then I'm printing it so that we can see. So if you come over here now, this is the memory location that contains the number 3, right? Because it's the number 3 that we set it equal to. It just so happens, and I don't know if this is gonna turn out right for us, but usually if you do this in a row and the computer knows that, hey, I've already pointed this, I've already binded this A to some memory location that contains 3, and you start doing it 2 or 3 times in a row, then what it does is it, instead of allocating new memory, it'll just point it to the same space. So hopefully it gives us the same memory address, and it does. So you can see now that this thing is 0.7, you know, I mean, not 0 times or x 7FFE. This is just hexadecimal talk for the same exact number. And hopefully it, here, let me Control V, and we'll change that to a 2. And hopefully it's the same thing as well. And maybe that didn't do anything or prove anything to you, but check out what happens here. What if I said A1 is equal to A1 plus 1, F9? Right, and then we print A1. Now, can A1 still point to that same memory location? Hopefully it doesn't make sense to you, right? Because that memory location, this 0x7FF, contains the number 3. So if I then did this again, hopefully it goes to a different spot. Yeah, look, so see what it did? So it changed it from D to F. And maybe if we did the same thing, then maybe it would change over A to a different memory location. But I just wanted to show you that the computer's smart in how it allocates memory. So that's one way of doing it, is just have it point to the same place if the number is equivalent. All right, so let's find out, make sure that what we thought happened. So A plus C makes sense. It's a float. A plus A is going to be an integer. See how it represents a float with the 0.0, and it represents an integer with just a number. And then A plus B hopefully gives us an error here because that doesn't make any sense. So it says, so this is our first error. Maybe not. Maybe I had an error above, but this is the first one that I meant to do. So type error, right? So that's telling you that there is an unsupported operand type. So an operand is the A and the B are operands for the operator plus. So for this plus, you can't have an int and a string. It just doesn't make sense to the computer. So it's telling you syntactically that I'm not supporting that. Okay, so let's find out what happens when we do A times 3, and we get 9, hopefully. B times 3, hopefully we get what we thought we should get. Yep, so we get 4, 4, and 4 all put together in a string. And then C times 3, we get 15.0. So that's, and that makes sense because it's an integer times so this 3 is an integer. C was a float. Any float times an integer will also give you another float. And then B plus B plus B. And it should give you the exact same thing as B times 3. And the cool thing about this is this mathematically, B times 3 is the same thing as B plus B plus B. But, you know, this is not math. I mean, this is concatenation, if you will. And Python has figured out that these should be the same. All right, it didn't have to. It could have decided to do something else with those operators. But it's cool that it does the same kind of thing. And then obviously A plus A will give us. Okay, so that's what we have there. So what is so important about being able to bind letters or names to memory, so to numbers, right? So that's really what we're doing, is we're binding these names to these memory locations that contain particular numbers. The important part of that is called abstraction, right? So that's one of the big ideas, abstraction. A big idea in computer science is being able to abstract something and not really think about that number anymore. I can think about the idea of that number. It's a big idea in computer science. So let's get an example. So from math import F9. Hopefully that one works. Yep. So we got the pi running around in there. And now I want to calculate the area of a circle. So I'm going to give you the radius. Radius is equal to 2.2. And then I'm going to have area equal to pi times, and then in parentheses, I'm going to have radius, and I really don't have to put the parentheses in there about it. I'm just doing it for readability purposes. Radius, and now this is how you do the exponent. So unlike other languages you might be used to, that is not that is something different. That is a different operator. It will give you something totally unexpected if you use that as your exponent. Sometimes it'll give you an error, but sometimes it'll give you a number because it thinks you know what you're doing. But that's really the exponent. So 2 multiplication signs. And then, so that'll give us area. So what I'm doing now is I'm sort of abstracting, like, so I have a circle, the idea of a circle, right? And now I have the idea of this radius. Well, we know what a radius is. So in our mind, we're thinking, okay, the radius is the length from the center of the circle to any point on the circle, right? So that's I've just abstracted that, that the distance from the point in the circle to the point on the circle, so that from the middle to the actual circle itself in any direction is 2.2. So in my mind, I'm just thinking, okay, the radius is 2.2. And now what I want to do is I want to abstract this idea of the area. So we're using what's called an expression. So this is an expression, and it's a mathematical expression, and it uses, please excuse my dear Aunt Sally, parentheses, exponentiation. I mean, all of it, please excuse my, so multiply, divide from left to right. Please excuse my dear Aunt AS is addition and subtraction from left to right. So it's just using the same order of operations that we're used to in order to evaluate this expression, and then that comes up to a number, and then that number is assigned to the area, to the letters area, or the variable area. So that's the thing that I've been looking for this. That's the thing that we're sort of trying to describe, is what is a variable. A variable is a name that we use to assign some number in memory. So some memory location that contains the number that we're evaluated, right? So what this thing does is it figures out, okay, there's some place in memory. I'm going to pull out, because this is let's see, 2.2. It would be a float. So I'm going to take some amount of memory or some amount of space in my computer's memory that can take this float, and then I'm going to assign the variable area to that memory location. Now, as a programmer, I don't really care about what that memory location number is, right? So up here, when we were doing this hex business, that's something that we just did here so you could see it, but it's not truly that important to us. At the end of the day, I don't care what memory. I'm going to let the computer sort of worry about that stuff. And then, but I'm interested in what sort of it is at that memory location. So in this case, it's just area. So Control or F9. Oops, I didn't. So F9, F9, F9. And then maybe we print area. We get this 15.205. And then what happens if we do area is equal to area plus 1? Print. Ooh, I didn't want to do that. Take that back. F9, F9. I don't want to do area is equal to area plus 1. I want to do radius is equal to radius. So then print radius. Okay, so let me just run everything again. So I had radius, and we know radius, we assigned it to 2.2, and then I executed this code here, which was the area is equal to pi times radius squared. And so if you did all of that math, you would find out, or evaluated that expression, you would find out that it's equal to 15.205. And then what we did was we added 1 to radius, right? So instead of 2.2 now, the radius is equal to 3.2, but that does not change. I mean, so I guess the idea here that I want to get across is I would have to run this again in order for it to change with area. area is still pointing to the 15.205, and it doesn't care the fact that you changed what radius was, because I evaluated that expression already. So if I printed area, we're still going to get the same 15.205 because it's evaluated when I hit the button here. It doesn't evaluate it because I changed radius. It doesn't know to go back and redo this unless we do it again. So let's do that. Let's evaluate it again, Control C. So I'm just going to copy paste this one down here. And then we see that it does in fact change it whenever I evaluated that sucker again. Okay, real quick, let's go back to OneNote and just remember sort of what's going on there. So what we've done is we've changed the bindings in this particular case. So we started off with something that maybe looked like this, where pi was equal to 3.4, radius was 2.2, and area, because after we evaluated it, we binded the variable area to 15.205. And then what we did was we came in and said, no, radius equals radius plus 1. So here, let me do another color. Let's go radius is equal to radius plus 1. So again, this here gets evaluated. So if it was 2.2 and I add 1 to it, then that gets evaluated to 3.2, and that number 3.2 is now binded to radius. Now this goes away, and then that becomes my new binding. But it didn't change what happened to area at all until I reran the code that said area is equal to, with 3.2 being the binding for radius. Again, abstraction. I've abstracted the idea that pi is 3.14, that radius is this particular number. I don't have to remember what the number is, and that area is equal to some expression that contains the radius in it. Okay, that's all I got for this lesson. Hopefully it wasn't as long as the last one.